With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, the resistance of each resistor in the circuit diagram shown in the figure is safe and is equals to 1 ohm. The potential across the terminal is 7 volt. Determine the current I that least if the resistance can be neglected. So if you see, this is the diagram. If you see here, right, from the symmetry, if you see there is a symmetry about this line. Can you see the symmetry about this AB line? Right. From the symmetry, if you see here, the point C and point D will be at the same potential. So you can just say that this is also at the same potential as that of the point C. So you can name this as C point only, right? So now if you see, these two resistances are connected between A and C, and these two connected between C and B. All right, and if you see here, this is the point O, right? So if I make another diagram, right, we want the equivalent resistance between A and O, right? So if you see here, between B and C, the two resistances are connected in parallel. So if two resistances are connected in parallel, so we will write down the R equivalent will be R1 R2 by R1 plus R2, so it will be R by 2, and the same will goes for between A and C. So let me draw the diagram. So if I say this point as A and this point as C, between A and C there is a resistance of R by 2. Now between B and C there is again a resistance of R by 2. So let's say this is B point. So here also resistance is R by 2. And if you see here, between O and C and between O and A and between O and B, resistance R and R is there, right? So if you see between O and C, there are two resistances, right? So between O and C, if I say this is point B, so if you see, this is the point O, and there is one resistance between B and O, that is of R, and between O and C there is a resistance R by 2. Since two resistances are there, if you see these two resistances between O and C, and they will be in parallel. So if you see, when the two resistances R and R in parallel, so it will be R by 2. So between O and C, I will draw a resistance R by 2. Like this. And between, if you see, between O and A, there is a resistance of R. Like this. So this is the diagram, right? If you see here, we want the equivalent resistance between A and O. See, R by 2 and R is in series. So the resistance of these two will be R by 2 plus R. It will be 3R by 2. And 3R by 2 and R by 2 is in parallel. So if I calculate the equivalent resistance of these three between C and O, so between C and O, it will be 3R by 2 into R by 2 in division, the sum of the two, R by 3R by 2 plus R by 2. So it is, if you see, 3R square by 4 in division, it will be 4 by 2R, so it is 2R. So this will get cancelled out, and it will be 3R by 8. Alright, so 3R by 8 is the resistance between C and O. Now it is connected with R by 2 in series. So if you see, we will write down the resistance of these two. So it will be 3R by 8 plus R by 2. So it is 4 by 8 plus 3 by 8. It is 7 by 8. Now 7 by 8 and this R are connected in parallel. Alright. So we'll write down the R equivalent is 7 by 8 R and R. So it is R1 R2 by R1 plus R2. So 7 by 8 plus 8 by 8, it will be 15 by 8. So it is this. This will be the R equivalent. Now the R is said in the question, it is 1. So R equivalent will be 7 by 5, 15. And the potential difference across the battery, the U is 7 and we want the current. So current will be simply equals to EMF by R equivalent. So it will be 7 by 7 into 15. So it is 15 ampere. And this is the answer. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.